Hi, and welcome back. So in this video, we're going to expand our discussion about the inverse trigonometric functions and start talking about using other angles. So this topic is going to require a calculator. So because we're getting other angles, these are going to involve decimals a lot of the time, and so we're going to need a calculator to find these answers. I don't usually like using calculators. I like doing as much by hand as I can because we're learning concepts, but I just want to be upfront here that we do need a calculator for this one. So for our example, let's look at the inverse cosine of -5/6, and we want to find what this is. So whenever we have an inverse trig function question, I like to write out the sentence of what question it's actually asking us. So here this is asking, what angle has a cosine value of -5/6? And specifically, inverse cosine is in quadrants 1 and 2. So this is looking for which angle in quadrant 1 and 2 has a cosine value of -5/6. So a quick glance at the unit circle will tell us that -5/6 isn't one of our values, and so the solution is going to be a different angle from one of the ones we're used to seeing on our unit circle. So my process here that I go through is I first look at the value and I see that it's a negative value, -5/6. Since my options are quadrant 1 and 2, I know that I must be in quadrant 2 since that is where cosine is negative. Then on my triangle, I remember that cosine values are an adjacent over hypotenuse. So I must have 5 as my adjacent side and my hypotenuse as my 6, since I have 5/6. And specifically, since we're in quadrant 2, that 5 is going to be negative, since our x value is negative. That horizontal amount is the negative amount. Also, we always choose a hypotenuse to be positive, so it makes sense to put the negative on this side of the triangle. Then our task is to find the angle that goes with this triangle. So if my sides are -5 and 6 for adjacent and hypotenuse, what angle goes with this? So we're going to just use a calculator for this. So really, actually, all of this work with the triangle, we didn't need this. We're just going to type cosine inverse of -5/6 into our calculator. So I'm just going to type in here to Wolfram Alpha, arc cosine of -5/6. I like to type arc cosine just so I don't have to deal with that exponent with the -1. And when I do this, it gives me a decimal approximation that is radians and the degrees. So I'm seeing that it's about 2.56 radians or 146.4 degrees. And there we go. That's my final answer. 2.56 radians or 146.4 degrees. So we can set up these problems a little differently, and I'm just going to show you one other way that they might show up. So this is about as complicated as these simple inverse trig functions go with these other angles. It's just really typing it in your calculator. Sometimes there's some setup to do, but really it's about this simple. I'll show you one example now where there's a little bit more work, but we're still going to use the calculator at the end. So let's find the measure of the angle theta in the triangle below. So I have one side that is 3 and one side is 10, and the hypotenuse is unlabeled, and we're looking for this angle theta here. So I'm going to draw this triangle so that it isn't clear which quadrant we are in, and this is to emphasize that we don't really need to know. We're just going to let the calculator do the work. So the calculator knows which quadrants are the options, and so we're just going to trust that the calculator can do it and figure out the quadrant for us. But we need to figure out which inverse function to use. So I'm noticing that from the angle theta, I have the opposite side, which is 3, and the adjacent side, which is 10. So opposite and adjacent refer to tangent. So I can set up a statement that says tangent of theta equals 3/10. But I need to find theta, so I'm going to rewrite this by swapping the theta and the number using the inverse function. So instead I can say arctangent of 3/10 equals theta. So this is asking what angle gives me a tangent value of 3/10. And we're just going to type this in a calculator. So again, I'm going to use Wolfram Alpha. So arctangent of 3/10 is 0.29 radians or 16.7 degrees. And it's in quadrant 1, and it handled that for us. We didn't have to worry about that. So that's our final answer. Our angle is 0.29 radians or 16.7 degrees. So as a note here, I just want to be clear that really you can use a calculator for lots of these problems, even with special angles. So for example, I could give you the question arcsine of -1 and ask you what this is, or arc cosine of 1/2. And you could just type these into a calculator or Wolfram Alpha and get answers. And it'll even give you the radian answers if you're using Wolfram Alpha. A calculator, depending on how fancy it is, may or may not do this. It might just give you a decimal, which really isn't as pretty and kind of gives away that you used a calculator, honestly. But I just want to be upfront. You really can use a calculator. However, I want to emphasize that we're trying to push ourselves to learn more than this. So we're not just teaching how to use calculators like as a technical skill, we're trying to learn how this works behind the scenes and how to apply this more in theory. So rather than focusing on just getting the right answers, we're trying to focus more on process and the conceptual part of it. So I'd like to encourage my students, whenever possible, to not use a calculator. It's a good way to check your work, but we want to really get into how these things are happening so that we could apply them in other contexts. And there we go. So that's about as complicated as it gets for doing the inverse trig functions with other angles. We have to do a bit more work with these once we start doing compositions, but for now, with just the single function, this is about as much as there is to do. So that's it for this one. Thanks so much for watching, and I will talk to you in the next one.